Welcome students. Today we are going to see rank of a matrix. Every matrix is given a rank. I mean whatever the matrix might be, all the matrix will be given a rank. Now we are going to find the rank of the matrix. To find the rank of the matrix, there are two methods. First method is minor method and second method is row reduction method, where the row reduction method is very important, right? Okay, now we'll see minor method. So first what you have to do is we have to name the matrix as A. So let A be a matrix of order m by n. Okay, m by n order matrix, and the name of the matrix is A. Now the rank of the matrix, okay, this is rank of the matrix A, okay, row. So rank of the matrix A, right? So rank of the matrix A is less than or equal to minimum of the order, given order m n. Okay, so that rank of the matrix must be either less than of any of the two. Okay, for example, if the order is 2 by 3 means 2 by 3 will be written here. What is the minimum of 2 comma 3? 2. So the order will be 2 or less than 2 means 1 or 0. Okay, we'll detail explain it. So first we have to name the matrix, then you have to write like this. And note an important thing that rank of a 0 matrix is always 0. Okay, rank of a 0 matrix is always 0. Rank of a identity matrix, unit matrix of order n is n. So this is very important. Okay, now we'll get into the exercise directly and I will explain you how to find the rank of the matrix using minor method. Now this is a given 2 by 2 matrix. Okay, now we are going to find the rank using the minor method. So I named that matrix as A matrix. A matrix. So first rank of the matrix must be less than minimum of the order. What is the order? 2 comma 2. Okay, so minimum of 2 comma 2 is 2 only. So the order must be less than 2. It means 2, 1 or 0. It won't be 0 because previously we learned if it is a 0 matrix then only the order will be 0. This is not a 0 matrix, so order must be 2 or 1. Okay, so first 2 means we have to find the 2 by 2 minor. 3 means you have to find 3 by 3 minor. 4 means you have to 4 by 4 minor. Can you understand? Right. So 2, so we have to find 2 by 2 minor. So 2 by 2 minor is nothing but this is already in 2 by 2 matrix. So we'll directly find this 2 by 2 matrix determinant value. So change this matrix into determinant and find the value. So 2 into 2 is 4 minus 1 into minus 4 is 4. So 4 minus 4 is equal to 0. So if you get equal to 0 means the rank is not 2. Can you understand? When you find the minor value and if it is equal to 0 means the rank will not be this. That means not 2. Suppose for 3 by 3 minor, you are finding the value. If it is 0 means rank will not be 3. Okay, so since it is not 2, possibly it is 1 only. So rank of A is not equal to 2. Therefore, rank of A must be 1. How means once we found that 2 by 2 minor is failed. So we have to go for 1 by 1 minor. 1 by 1 minor means this individual element. So take one individual element. It is 2. It is not 0. Isn't it? 2 is not 0. So therefore the rank will be 1 only. Can you understand? We'll get into a few more examples. So you will explain. You will understand it well in detail. Okay. Now sum number 2, that is subdivision number 2. Now see, this is a matrix. Okay, the order of the matrix is what? 3 by 2. So I named it. So rank will be less than minimum of the given order, that is 3 comma 2. So minimum of 3 comma 2 is 2 only, isn't it? So the rank will be either 2 or 1. It is not 0. So we have to go for 2 by 2 minor. So 2 by 2 minor. From this matrix I can write not only one 2 by 2 minor. I can write many 2 by 2 minor. So first I will take one 2 by 2 minor, that is minus 1, 3, 4 and minus 7. Okay, first I have taken that 2 by 2 minor and I find the value of the matrix. So minus 1 come into minus 7 is 7, minus 4 into 3 is 12. So subtracting, I have got minus 5. Minus 5 is naturally, it is not equal to 0. So if it is not equal to 0 means this is the rank. If it is equal to 0, this is not a rank. It is not equal to 0, so this is the rank. So rank of A is equal to 2. Subdivision 3. Now name this matrix as A. Now we have to write the order. The order is 2 by 4. So minimum of 2 comma 4 is 2. So rank of A is 2. Okay, minimum of the 2 comma 4 means this 2 is the smallest number. So 2. So the rank of A is less than 2. So 2 means first I have to find the 2 by 2 minor. I have taken the first 2 by 2 minor as 1, 3, minus 2, minus 6. You can take any 2 by 2 minor. 1, 3, minus 1, minus 3, or 1, 3, 0, 1, or you can take minus 2, minus 6, minus 1, minus 3, like that. You can take any sort of 2 by 2 minor. Okay. So first I have taken the first column and the second column. I made a 2 by 2 minor. So I find that 1 into minus 6 is minus 6, minus 3 into minus 2 is minus 6. So it is plus 6, which is equal to 0. So once I find this is equal to 0, I cannot drop it because I can make few more minus. I have to check all the minor. Can you understand? I have to check all the minor. If all the minor failed, means the rank will not be 2. Can you understand? Right? If even one minor gives the value which is not equal to 0, means the rank is 2 only. So I have to check all the minor. So I'll go for the next minor, taking the first column and the third column. Okay, so first column and the third column, I made this determinant. So 1 into minus 3 is minus 3, minus 1 into minus 3 is minus 3. So plus 3, which is equal to 0. Again it failed. I am going to take another minor. I am going to take the first column and the fourth column. First column and the fourth column. So first column and fourth column is written. So now 1 into 1 is 1, minus 3 into 0 is 0, which is 1, which is not equal to 0. So here it failed. So it is, the rank of the matrix is 2. Suppose this is also equal to 0 and all the minor from this matrix is 0, means rank is not equal to 2. It is naturally 1. Now we'll get into the next subdivision. And again a matrix is given. Name this matrix as A. So find the order of the matrix, which is 3 by 4. So minimum of 3 comma 4, which is the minimum value in 3 comma 4, it is 3 only. So the rank of the matrix must be less than or equal to 3. It means it can be 3, 2, 1 or 0, but 0 is not possible since this is not a 0 matrix. So 1, 2 or 3. So 3 means first we start with 3 by 3 minor. So to find the 3 by 3 minor, I am going to take the first column, second column and third column. Okay, I have taken that. Now I am going to find the value of the determinant. I am going to expand through the column wise, not in row wise. The reason is two values are 0, so it is very easy to expand through the column. So first element is 0, means I don't want to expand this value, so take it as 0. Second value is also 0. The third element is 8, so this is plus, minus and this is plus, so it is 8. Leave the row and column. So these are all the 4 elements. 1 into 4 is 4, minus 2 into 2 is 4. So naturally 8 into 0 is 0. So here it is failed, but still I can make few more 3 by 3 minus. So I will check all the 3 by 3 minor. Okay, so now I am going to take the first column, second column and the fourth column, and I made a determinant. Now the same way, first element is 0, leave it. Second is also 0, leave it. Third is 8, leave the row and column. 1 into 3 is 3, minus 1 into 2 is 2. Now 8 into 1 is 8, which is not equal to 0. Therefore the rank of the matrix is equal to 3. Now we are going to find the rank of the matrix using the second method, row reduction method, which is an important method. So row reduction method, now I will give you some rules to be followed. This is very important. If you are unable to understand the rule and if you didn't fail to read the rule, means you will not be able to proceed this method, and even further coming exercises will based on this row reduction method only. So please learn and please read this. I will explain in a easy way. So okay, first in row reduction method, our first goal is to convert the given matrix into row echelon form. And what is row echelon form is given here. See, this is the row echelon form. This is the given matrix. I have to convert this given matrix into this way. What is the meaning? So this is the main diagonal, isn't it? 1, 1, 5. Below the main diagonal, I have numbers 2, 3 and 0. Our goal is to make all the numbers below the main diagonal into 0. Can you understand? So while try to change this number into 0, these number will also change. That doesn't matter. Can you understand? Row echelon form means in the given matrix, in the main diagonal, all the elements below the main diagonal must be 0. You have to convert that into 0. If you try to convert that into 0, the remaining elements may change. That doesn't matter. Okay. So this is row echelon form. To convert this row echelon form, usually what will you do means we will make the first element, first row, first element. Okay, make the first row, first element is missing. Make the first row, first element as 1. See, this first element is already 1. If it is not 1, make it 1. This is optional only. It is not a must to make it 1. If you make it 1, it is very simple. Okay, very easy. Why means I will explain in the example. So make the first row, first element 1. Then using that element, change all the elements below it as 0. Using this one, convert these elements like 2, 3 as 0. Repeat step 1 and 2 until you reach the row echelon. What is the meaning? Second element is 1. Using this element, make the below element 0. And third element is 5. Below 5, there is no element. Can you understand? Can you understand? In the main diagonal, using the first element, you change the elements below as 0. Then this is the second element. Using that, change the below element as 0. Third element, such a way it goes on until you reach this row echelon form. Can you understand? Okay, so row echelon form. What is the row echelon form? The main diagonal, all the below elements supposed to be 0. How to make it 0? Using the first element, you have to make the complete column 0 below it. The second element and make the complete elements below it as 0. Such a way it goes on. Okay, so to make this 0, what should be done? To make it 0, these three methods can be used. That is interchange any two rows or column. That means you can interchange the first row with the second row, or second row with the third row, first row with the third row. Like that you can interchange any two rows or column, but don't take this column. Okay, usually try to do it with the row itself. Even if you do with column, it doesn't matter, but my advice is always go with row. Okay, right. Now multiply any row or a column by a non-zero scalar. It means you can multiply this complete row by any number. For example, this row can be multiplied by 2, means what? 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6. Okay, then multiply a row or column by non-zero number and add with any other column. So you can multiply this 1 by 2 and add with any of the row. So 2 plus 2 is 4. Such a way you can do it. Okay, it is little bit, you find it little difficult. When you go with the example, it is very simple. Can you understand? Right, we'll start with the example. Now exercise 1.1, sum number 2, subdivision 1. Using the row reduction method, we are going to find the rank of the matrix. So given matrix is this, name this as A. Now what is our main goal? This is the main diagonal. Elements are 1, minus 1, 7. So we have to change this to 5 and minus 1 into what? 0. Okay. So first change the first row. First element is 1. It's already 1. Now using that 1, you have to change this 2 as 0 and 5 as 0. It is very simple. First we will take the first row element and multiply by 2. So first row is multiplied by 2. 1 into 2 is 2. 1 into 2 is 2. 1 into 2 is 2. 3 into 2 is 6. So why did I multiply it by 2? Means this is also 2. Since this is 2, this element is already written here. Okay, for understanding purpose I have written here. You don't want to write it, right? So first row is multiplied by 2 because the second row first element is also 2. So if you make this as 2, subtracting these 2, you will get 0. Can you understand? So the reason we make this as 1 means what number you want, that you can simply multiply by that number since you have it as 1. Here I have 2. So if I multiply by 2, I will get 2. Here I have 5. If I make this 5, I have to multiply by 5. Can you understand? Okay, so first row is multiplied by 2, second row is written as it is. Now we are going to subtract. 2 minus 2 is 0. Can you understand? Write the first row as it is. Second row only we are changing. 2 minus 2 is 0. Minus 1 minus 2 is minus 3. 3 minus 2 is 1. 4 minus 6 is minus 2. So we change the second row. So how it changed? Row 2 implies row 2 minus 2 times of row 1. Can you understand? Row 2 minus 2 times of row 1. Okay, the same procedure will be done for the third row. Since this is 5, I have to multiply the first row by 5. So 1 into 5, 1 into 5, 1 into 5, 3 into 5, 15. So write this third row element here. Same subtraction is done. 5 minus 5, 0. Minus 5 minus 1 minus 5 is minus 6. 7 minus 5 is 2. 11 minus 15 is minus 4. So row 3 implies row 3 minus 5 times of row 1. Row 3 changes. How? Row 3 minus 5 times of row 1. Right. Now we made all the elements below the first row first element as 0. Okay, now the second element in the main diagonal is what? Minus 3. Now this 6 has to be made into 0. Very simple. When you multiply 3 into 2, you will get 6, isn't it? So that's what I'm going to do. So use the second row is now to be multiplied by what? 2. 0 into 2. Minus 3 into 2 is minus 6. 1 into 2 is 2. Minus 2 into 2 is minus 4. Now write the third row element as it is. Now subtract it. 0 minus 0 is 0. Minus 6 minus of minus 6 plus 6, so 0. 2 minus 2 is 0. Minus 4 minus of minus 4 is plus 4, it is 0. Now over. Now you see this is the main diagonal. All the element below the main diagonal, now it becomes 0. How it becomes? R3 implies R3 minus 2 times of R2. Now how to find the rank? Once you form the row echelon form, now you have to identify how many rows are there without completely 0. Can you understand? First row, no zeros. Second row, there is 1 0. So you can consider that is a row. First row is considered as row. Second row is also considered. But third row, all the elements in the row is 0. It means that row is vanished. That row is vanished. Suppose if you have one element without 0 is also means that row is not vanished. Can you understand? All the elements are 0 means that row is completely vanished. So since one row is vanished, we have only 2 rows are there. Therefore, the rank of the matrix is nothing but it is 2. Suppose this row is not vanished, the rank of the matrix A is 3. Since one row is vanished, the rank of the matrix is 2. Now subdivision 3, let name this matrix as A matrix. Now what we are going to do is we have to find the row echelon form. So how to make it a row echelon form is very simple. I told that first row first element is 1 means it is easy. So I see here there is a minus 1. 1 or minus 1, no problem. So I'm going to interchange the first row with the second row so that I can easily do it. So first row is interchanged with the third row. Row 1 interchanges row 3. So first row is written in the first row is now put into third row and third row is put into first row. Okay, right. Now what you have to do is make this 2 and 3 0. Okay, so using this minus 1. So what should be done? Since this is 2, I can multiply this also by 2. So first row is multiplied by 2. So it is minus 2, minus 4, minus 6 and minus 4. Write the second row as it is. Now you don't want to subtract, you have to add. Because when you add only you will get what? 0. Suppose there is no minus means we have to subtract. So adding these two it is 0, adding these two it is minus 1, adding these two it is 7 and adding these two it is 0. Now make this 3 as 0. For that multiply this row by what? 3. So 3 means minus 3 into 3 is 6 into 3 is 9 into 3 is minus 6. Now write the third row. Again you add it 0. Adding these two minus 2, 9 plus 5 is 14, minus 6 plus 2 is minus 4. Okay, so we made some changes. So that has been written here. R2 implies R2 plus 2 times of R1 and R3 implies R3 plus 3 times of R1. Okay, now what you have to do is using this one, I have to make this particular element as 0. Now what should be done here? It is very simple. You have to multiply this row by 2. If you multiply this row by 2, this becomes 2. So when you subtract this, you will get 0. Okay, so second row is multiplied by 2, so it is 0. Minus 1 into 2 is minus 2, 7 into 2 14, 0 into 2 is 0. Now write the third row as it is. Now we have to subtract it. 0 minus 0 is 0, minus 2 minus half minus 2, so plus 2, which is 0. 14 minus 14 is 0, minus 4 minus 0 is minus 4. Right, so R3 implies R3 minus 2 times of R2. Now we achieved it. This is row echelon form because all the elements below the main diagonals are 0. Now you check it. First row, it doesn't vanish. Second row, 2 elements are there, doesn't vanish. Third row, minus 4 is there. Suppose it is 0, it is vanished. So 3 rows are there, it doesn't vanish. So the rank of the matrix A is 3. Now find inverse using Gauss-Jordan method. Now we are going to find inverse of a matrix. Suppose this matrix is named as A, we are going to find A inverse. You know how to find A inverse, isn't it? A inverse is equal to 1 by determinant A into adjoint it, but you must not use that method. Even answer is correct, but method is wrong because it is Gauss-Jordan method. Gauss-Jordan method is very simple. I'll explain it. So first what you have to do is you have to write in this form A bar I. That means A matrix is written a separator, then you have to write the I matrix. What is the I matrix? Unit matrix is written. Now our main goal is to make this particular 4 element into what? This 4 elements should be converted into I, that is unit matrix. Once you convert this into unit matrix, you will get some value here. That is nothing but A inverse. Okay, right. So first goal, what is the first goal? I want this first element as 1. So to make this first element as 1, simply I divide by 2, you will get 1. But I am not going to do that because fraction, some students may commit mistake. So I am going to try a little different method. I am going to multiply the first row by 2. Okay, see, multiplying first row by 2, it is 4, minus 2, 2 and 0. Now second row element is written as it is. Now I am going to subtract it. That is 5 minus 4 is 1. That is written here. Minus 2 of minus 2 plus 2 is 0. 0 minus 2 is minus 2. 1 minus 0 is 1. Right? Can you understand why I did so? Means now I can interchange the 2 rows. So I will get the first row first element as 1. Okay. Right? Even you can divide this first row by 2 and you can do the sums. Right? So R2 implies R2 minus 2 times of R1. Now I just interchange the row. R1 implies R2. So second row goes in the first place and first row comes in the second place. Now using this 1, I have to make this 0, so that I have to multiply the first row by 2. So multiplying first row by 2, it is 2, 0, minus 4 and 2. Second row is written as it is. So I have to subtract. So 2 minus 2 is 0. 1 minus 0, minus 1 minus 0 is minus 1. 1 minus of minus 4 is plus 4. So it is 5. 0 minus 2 is minus 2. So R2 implies R2 minus 2 times of R1. Now we made a part is okay. Now this is 0. Now this particular element should be 1, isn't it? Unit matrix, main diagonal should be 1, or remaining elements are 0. So I have to make this particular element into 1. It's very simple. Just change the sign, you will get it. So changing the sign is nothing but multiplying the second row by minus 1. R2 implies minus 1 into R1. So change the sign and write the value. Now here we have got the identity matrix, that is unit matrix. And here you got some value, that is nothing but A inverse. So A inverse is minus 2, 1, minus 5 and 2. Subdivision 2, this is an important 5-mark question. Okay, this is an important 5-mark question. Now this matrix is A, this is a 3 by 3 matrix. So now I told that A by 1, right? So this is A by I, which is a unit matrix. So A matrix is written, this is an unit matrix. Now we have to convert this into what? An unit matrix. So for that, first row first element is already 1. So we can proceed it. So now first row is already 1, so I'm going to multiply this row by, so it's already 1, here also 1, so you can simply write the first row and the second row and subtract it. 1 minus 1 is 0, 0 minus of minus 1 is plus 1, minus 1 minus 0 is minus 1, 0 minus 1 is minus 1, 1 minus 0 is 1, 0 minus 0 is 0. So R2 implies R2 minus R1. Now this 6 has to be eliminated into 0, so multiply the first row by 6. 6 minus 6, 0, 1 into 6 is 6 and remaining are 0. Now write the third row element and subtract it. 6 minus 6 is 0, minus 2 plus 4. Since minus and minus it is plus 6, so it is 4. 0 minus 3 minus 0 is minus 3, 0 minus 6 is minus 6, 0 minus 0 is 0, 1 minus 0 is 0. R3 implies R3 minus 6 times of R1. Now this is okay. Now using this one I have to make this 4 0 and also the minus 1 into 0. Can you understand? This element I have to convert these two elements 0. Now this is very simple. I can simply add these two to make it 0. It is very simple. Okay, so write the first row, write the second row and add it and write it. So adding these two it becomes 1, adding these two it is 0, adding these two it is minus 1, adding these two it is 0, adding these two it is 1, 0 plus 0 is 0. So row 1 implies row 1 plus row 2. Adding these two you have got the first row. Now this particular row has to be changed, making this as 0 and write it here. So for that this second row has to be multiplied by what? 4. So second row has to be multiplied by 4. When you multiply this row by 4 you will get like this, isn't it? So now second row is multiplied by 4. Now write the third row and subtract it. 0 minus 0 0, 4 minus 4 is 0, minus 3 plus 4 is 1, minus 6 plus 4 is minus 2, 0 minus 4 is minus 4, 1 minus 0 is 0. R3 implies R3 minus 4 times of R2. Right, now using the last element, this one, I have to make these two elements 0. It is very simple. You can add the first row and the third row and write it here. Add the second row and third row and write it here. You can directly, without writing here also, you can directly do it. Okay, add the first row and the third row. So 1 plus 0, 1 plus 0 is 1, 0 plus 0 is 0, minus 1 plus 1 is 0. 0 minus 2 is minus 2, 1 minus 4 is 3, 0 plus 1 is 1. Right? Now to make this element 0, add the second row and third row. 0 plus 0 is 0, 0 plus 1 is 1, minus 1 plus 1 is 0, minus 2 is minus 3, 1 minus 4 is minus 3, 0 plus 1 is 1. Now you have got here an identity, that is a unit matrix. Right hand side you have got some value which is A inverse. Therefore A inverse is minus 2 minus 3 1, minus 3 minus 3 1, minus 2 minus 4 1. That's all. Thank you.